Good morning, good afternoon, and good evening to all. Welcome to the HyperWorks 2022 on CAD geometry and meshing. In today's session, we will be taking you through all the new workflows and the features that have been introduced in HyperWorks 2022. So, what are the new features and capabilities that we've introduced in HyperWorks 2022? The first thing and the biggest thing we've introduced in HyperWorks 2022 is the introduction of FE geometry. Now you can have mesh you can treat mesh as FE geometry. So there's a series of slides follow. I'll take you through all the details. The other new workflow we've introduced is the associate context under the edit elements. With the associate context, you will be able to visualize nodes associated to any edges, vertices, or surfaces. New tool basically which migrates the trim and the untrim functionality, which can be found under the split context. You will have a drop down for the unsplit through which you can use the trim and the untrim options. Uh, the workflows enhanced are all of the geometry tools in HyperWorks basically support FE geometry. So if you have any mesh as a FE geometry, most of the tools, except for a few exceptions which are listed in the help, all are supported for FE geometry. And direct mid mesh. So basically, the mid mesh output is always in FE geometry. So we no longer support creation of mid mesh with 1D lines as topological lines. So everything is FE geometry. So with FE geometry, you basically we can create new topological surfaces as FE geometry, or convert existing mesh basic or any FE into FE geometry. You also have the option to basically convert your complete solver deck into an FE geometry. So if you have a solver deck and if you import it, you have the option. So all of the mesh information from the solver deck converts into an FE geometry. Um, with In the 2022 batch measure, we have added an option basically where we provide user the option to aggressive quality correction. Basically, it makes more aggressive node movements, basically to reduce the number of element qualities failing from batch measure. On the on the mesh control side for surface meshing, there is a new option for local map mesh as well as edge biasing or mesh controls. Also, in the surface mesh controls, we have added feature identification basically for high curvature features such as cylindrical features and stuff. As well as washer creation options from the mesh controls. So from the CAD interfaces side, the latest CAD format supported with HyperWorks 2020. We support NX 1969 through a third party now. The NX 1969 through the native reader was already supported in our previous .2 2021.2. Also, we've added support for Creo 8.0 as well as all neutral files generated from Creo 8.0, and also upgraded the Parasolid version support to 33.1.154. Some of the capabilities we've improved from the CAD side is we have improved performance on model import, especially having large number of fillets or large number of bodies. So there used to be a little bit of slowdown from a third party, so which has been improved. And also from the CATIA parameter import. So parameters which had spaces were not imported into Hypermesh. This has been fixed in the current version as well. As we also fixed instant to match CATIA instance attribute names with same as in the same form as you see in CATIA. From the geometry side, as I mentioned earlier, FE geometry is the biggest enhancement and a new feature introduced. Uh, apart from the um, Apart from the FE geometry, other features that has been added are the auto cleanup in the defeature batch tool. The defeature batch tool, you can use basically the param and the criteria files to do the element auto cleanup of the surfaces as well. Also from the sketches side, the intersect plane, now you can intersect and obtain a plane from basically 2D and 3D element support. Initially only geometry support was there. Now you could do intersect on 2D and 3D elements as well. Also, the from the surface patch tool, we've improved the performances as well as the capability. So the patch tool has improved loop detection and stitching methods. So when you fix patches, you should have a clean geometry. So let me introduce you to FE geometry. What is FE geometry? FE geometry is basically topology on top of a mesh. Um, Top of a mesh. It's like having permanent edges, faces, and vertices on a mesh without having to have a CAD. All of the model setup workflows downstream going forward will, like for example, loads, contacts, boundary conditions, all of them can be defined on the geometry on the agnostic of the mesh. So FE geometry basically it's CAD and mesh which exist as a single entity. So you don't have like a surface or a mesh. So it's like both as one are the same entity with FE geometry. So all tools, basically geometric tools or all mesh workflows um, that that used to operate on CAD operates in the same way with FE geometry as well. So there will be similar workflows, similar options, and it can be used in the same. So there are no two different ways to work with FE geometry. With the introduction of FE geometry, selections are made easy. So now you could select basically mesh as any particular on clicking on a surface is basically the whole selections are improvement. So mesh selections are much easier now. FE geometry, with the introduction of FE geometry, mesh editing is way improved. So I'll take you through some of the workflows a little later on where we see the efficiency in the mesh editing. Last but not the least, I would like to remind this: FE geometry is not a replacement for any CAD associated mesh. If you have CAD and if you're meshing on top of CAD, I suggest to proceed with that and not convert it at this point to everything into an FE geometry. So FE geometry has to be used where you don't have CAD, where you have a mesh and you don't have CAD for it. So where can you create this FE geometry from? There are two entry points from where you can create FE geometry. The first entry point is basically from the geometry FE geometry context, and the second one is basically on import of solver deck. So when you come to the FE geometry context in the geometry page, you basically have three options. The first option is basically if you want to convert CAD associated mesh to FE geometry. In case there is a need for you to convert any CAD associated mesh to FE geometry in your workflow, you can use the first option from CAD. I suggest not to use it in all cases. Use it only when it is required. Is this option? The second option is basically from elements. What this means is whenever you have in your model just a mesh, you can convert them into FE. You can convert them into FE geometry. And once the mesh is converted in FE geometry, you are allowed to work with any of the geometric tools on directly on the mesh. The third option is basically to update the FE geometry. Say you imported a solver deck, or you converted the elements to an FE geometry, you still did not get the right amount of fillets or fetches. So you can basically tune your FE geometry to have more features identified. So these are the three options from where you could create or update FE geometry. The second option is basically when you do a solver import, you have this option, new option you would see on the solver import option, which says FE geometry. So once you select the create FE geometry, all of your mesh from your solver deck basically gets converted into FE geometry on import. Going ahead, uh, these are other contexts from where you can create FE geometry. So basically, creation of FE geometry on primitives. So basically, surfaces, lines, and solids. So uh, from the to create FE geometry from each of these contexts, the preferences must be changed. So in the preferences under geometry, you have this new option now under create mode as CAD geometry or FE geometry. When the mode is set to CAD, like today, in today, any geometry that is created from these contexts would be CAD only. If the creation mode is switched to FE geometry, then basically the shapes and the surfaces or the lines, FE lines, or solids will all be FE geometry. So when we create FE geometry, there are certain rules, creation rules that we've applied. For example, when you have um, two CAD inputs, the expected output is always CAD. No matter what is the creation mode, even if you set it in FE geometry, if the two inputs you're giving to any of the tools is CAD, the output is always CAD. So as an example here for creation of a ruled surface, if I provide two CAD edges, the output is basically a CAD geometry. In the second case, I have a FE geometry of two surfaces, and to create a rule between these two surfaces, I'm providing these two geometry edges. So basically, the output is an FE geometry surface. In the case of mixed input, say you have one surface with CAD and another surface with FE geometry, and if you provide one CAD edge and one FE edge, the output is basically we always create a CAD. So for any mixed case, the output will always be a CAD geometry only. So these are the rules that we followed in the process of creation of FE geometry. So just like we have with CAD, when we do editing of CAD topology, the CAD topology revisions, we have a similar for FE topology revision. So if you don't want to change any of the existing mesh, you can always keep it in mesh. The FE geometry, when edited, the mesh will not be remeshed or anything. But as a if the option you can set it to remesh or rebuild. So basically on any topology FE geometry topology revisions, it we can do the remesh or the rebuild on either of the affected surfaces, or on the number of layers you can specify it should take an effect on where the topology is edited. So coming to the FE geometry visualization in HyperWorks, the visualization of FE geometry for CAD and FE geometry is almost the same. Hypermesh treats CAD surfaces or FE geometry surfaces the same way, except for a few exceptions. I'll go through each one of these listed exceptions in independent slides. So when you have a FE geometry surface, so as you see on the right hand side, I have a FE geometry surface, and from any of the browsers behavior is only the CAD icons have an effect. So clicking on the CAD icon, basically we show the surface along with its elements. If you turn off the CAD icon on the FE geometry surface, basically nothing is visible. The surface is also not visible, as well as basically the elements as well. And For FE geometry entities today, basically the FE icon does not have any effect at all. So no matter whether you click on the FE icon, basically there is no effect. So only the CAD icon has an effect. Second exception we have is basically on the hide and no, for the hide and isolate have slightly different behavior to our general CAD plus mesh. So if you have a surface and you do a selection of partial elements and say hide, basically the complete FE surface gets hidden. So this is a behavior we have now. We um, will basically improve it with more infrastructure changes going forward, but currently it's a limitation. So when you hide elements, basically all the elements associated to its surface gets hidden. Similar behavior you will have for 1D elements. So when a FE line created from 1D elements is created and you select partially an element, basically the complete line gets hidden. Similar behavior is seen for similar to hide. We have the isolate behavior as well. So when we do a partial selection of elements and do isolate, its surface associated would be isolated. Um, for the 1D elements as well, isolate would basically isolate the complete line display. So when you have enclosed FE, when you have enclosed mesh, basically it creates an FE solid. So whenever you have um, like here in the example, a cube is all enclosed. So basically when the conversion happens, it gets created into an FE solid. So hiding partial elements from FE geometry solid will have no visualization effect because solid has a more solid wins over here, and basically when you do a selection of this elements and say hide, nothing you will not feel as nothing is hidden because the solid is there. In this case, if you want to have the original, you can delete the solid, so then you have the surface behavior and then you can do the hide option. So selection of, like with surfaces and lines, any selection of partial lines and then doing a isolate will basically bring the complete isolation of the solid. So here it was a solid, so that's the reason you see it's this full FE solid is isolated, to which is isolated, and the other solid is hidden. Delete functionality. How does delete work with FE geometry visualization? So basically, if you delete elements on an FE geometry, it basically takes away its geometry along with it. So like here you have a selection. I do a square selection of elements and I say hit delete of elements. Basically, the elements are deleted along with the geometry, and you have a surface edge created in it. Um, the other option is basically if you delete basically the surface, you have the option, it'll ask you, you have the option where do you want to retain elements, and in that case the FE geometry would turn into orphan elements. um, Also, we have to take a look at the organizing behavior with FE geometry. So in this case, I have a FE geometry surface where the geometry as well as the elements are in one component. So now if I move this surface to another component, what is the behavior? So when you move these surfaces from one component to another component, basically the elements also move along with the surface. So here I have this elements um, surface. I'm moving from component 1, which is brown, to component 2. So the elements also move along with the surface. So we have this new behavior where you want to organize elements from one single surface into different components. So we allow the option to move elements from a single FE surface to multiple components. In this case, now I'm moving a set of elements at the center of the plate to a new component, component 2. So when you move this and From the visualization side, basically the surface behavior takes higher priority. So even though the elements is moved, you don't see here as these elements moved, because since FE geometry, both surface geometry and elements are one at the same, you don't see this behavior as moved. So in order to visualize this effect, we have a new visualization behavior which is called as FE component. So if you switch from component to FE component, then you could see the organized behavior as where the elements are sitting with respect. Once I would like to highlight here, once you move this FE geometry elements basically from the surface component to a new component, this is the visualization behavior. But the new component which has nothing but the element visualization will have no effect. So basically the CAD icon or the FE icon, they will not have any effect because the geometry is not there in it. So the switching on the surface or the elements will happen only from the component where the surface sits. And also when you do element show all, this is basically, since it's all FE geometry, when you do elements and say show all, basically we turn on these surfaces, because there's no way for us to show just elements without the surfaces. So these are the few exceptions, a few exceptions with respect to the visualization of FE geometry. Moving on to the editing tools. So here's an example from split tool. Basically, you can split. Now you have a FE geometry, which is nothing but a mesh here. So you can use the split tool to split with plane. So previously we couldn't split any mesh with plane. Now with the introduction of FE geometry, we can treat it just like any CAD and do the split operation on mesh. Another example here to use a drag tool. Say you have you have a whole with a whole flange which is not captured properly or was missed. So with the introduction of with FE geometry, all you have to do is basically select the edge of the hole here and just drag along its the direction, and then the surface is created as well as along with the mesh. Here's another example of a surface extent tool where you have a new geometry and an old mesh, and you would like to extend the mesh extend the mesh. So all you need to do here is basically you select the three edges of the FE and then drag along the direction to update it to the new geometry. So mesh editing is just like CAD editing now. Here's another example where we can do an imprint of a missing feature. You can imprint the midline from the top rib to the bottom edge, and then basically you can also create the patch. So any operations is specific to FE geometry or CAD, under the menus you would have the different options for CAD and FE, and you can choose the respective ones. Here's another way to create quickly a mesh using another drag option. Here I'm just dragging this edge along with a guide. So you select an edge and then you provide the guide, and then the surface gets created with the mesh. So here's another ruled option. The ruled Using ruled, basically I create the missing rib, and then once the surface is created, I just drag the edge of the created stuff onto the base plate, which stitches the mesh to it. So before I show a couple of examples, I'll just go through a quick demo of FE geometry. So here is a model that I have imported, and for the creation of FE geometry, you have to come to the geometry and from the FE geometry context. So in this case, I have only mesh here, so I'm not using the first option. I would use the second option, which is elements. And you can select all of these elements and then hit convert. So basically the normal mesh FE mesh has been converted into FE topology. So if you switch it to the topology mode, you see here the mesh is now behaves like CAD. So I can go to surfaces. Here, this is a surface. So selections are easy. I can select lines. So basically this 1D elements were converted to lines. So let me go to the mask browser just to show you a couple of things. So if I select, so since I had all 2D meshes, so if I switch off these surfaces, so basically all my 2D mesh are gone. So any enclosed 2D meshes are created as FE solids. So I can switch off the solids here. And 1D elements, basically 1D elements from lines, I can switch off and stuff. So today at present, we don't support solid elements. This is in the next version, we will support solid elements. So that's the reason we don't convert any solid elements into FE solids as yet now. So going back to some of the visualization behaviors I mentioned. So basically with elements, so for example, if I'm picking only few elements and then say hide, basically the surface to which this all the elements of that particular FE surfaces gets hidden. Similarly, it would be for isolate behavior as well. If I right click and say isolate, basically all the elements on the surface would be isolated. So this is a current limitation we would certainly improve going forward. And say surface, I can say you can do element selection as surface itself, then move to elements. So basically it jumps over to the elements. So just in one click, you can select all of the elements by surface options. So if I can do a surface, I do an isolate here. So if I delete elements from here, basically it creates, it deletes geometry along with it. And if you go ahead and do the surface deletion, as I mentioned, um, when you say surface, I can say if you have this option to retain the elements or not. So if I don't, the full surface gets deleted. So going ahead, I would like to quickly go through some of the workflows and where we see the advantages of using FE geometry compared with our classic workflow. Uh, in this uh, um, in this workflow, we would like to create how easy it is to create a mesh between a rib and a base using the imprint tool. So all you do is basically select an edge, select the target, and hit imprint. So it's basically within 3 clicks, a rib has been created, and the time taken around 8 seconds. In the old workflow, basically, we'll have to create the 1D edges that forms the loop. Once the loop is formed, we used to do the fill of that loop and then align and do it. So um, the advantage you see here with 12 versus 3 clicks and 8 seconds to 30 seconds. Here's another example. We want to create a ruled mesh between edges. So all you do is select the two FE edges and then create a rule. So you select the two edges and then hit create. Whereas in the previously with the 1D lines defining the topology, we always have to do a fill and then do. So the number of clicks reduces as well as the time taken. Another example of using stitch on FE geometry using imprint. So here You can extend basically the source to the target. So you select the FE edge where you want, and you select the extend the source to the target, and that gets stitched to the target surfaces. So we've eliminated basically uh, the creation of 1Ds and stuff so that editing can be faster. So in this example, basically when we have some features that are not captured correctly, we can quickly recreate them using the geometry tools instead of meshing methods. So here the cylinder was not extracted properly. All I would do is select the edges and then drag along it. So in the previous methods, there was no option to basically select edges and stuff. So we had to create all of these four faces individually, fill them up, and then basically do a rebuild on it to create the um, missing cylinder face. So many of the mid-mesh workflows will have a significant impact with the introduction of FE geometry. Here we've done the operation in 14 seconds versus a minute with the old methods. So we can also connect mesh using stitch now. So in this case where you have um, the stitch operation, so basically you can select the edge and drag along it to connect with the mesh. Whereas in the previous case, we had to use the replace tool, do a multi to multi select to do a replace and stuff. So or you could try equivalence, but sometimes it might not come correctly. So here is just a one-click solution to connect my disconnected mesh. Here's another example of splitting mesh by plane. Uh, i- so here you could just select the surfaces and basically do a split with plane. In the older method, uh, the way we could do this was basically to um, trim the outer solid, and then basically imprint onto the mesh, and then get it. Another efficient way to work on mesh with geometry tools. And then finally we would have to do the rebuild. Here with the preferences options set, basically we can get the rebuild also done automatically on the affected surface or the number of layers adjacent. Here's another example of removing unwanted edges where so so basically from the stitch tool you can select the surfaces, provide a feature angle, and then basically all the unwanted edges would get removed automatically. In the other case, when we had to deal with geometries, we had to delete them individually, or a group selection would delete also the required edges. So you don't have to worry in this case here, since they're all topological edges. It is taken care. So here's another example of using the cut hole to basically create holes. So in from the cut hole, basically, you can select the surface where you want to generate the hole, and then basically the rebuild behavior with the cut hole automatically takes care, and also the washers have been done. Whereas previously we would have to create a circle, imprint the circle, and then do a rebuild of it. So another example to remove unwanted holes in the model in geometry editing. Um, you could find all the holes using the patch tool. From the patch tool, once the holes are done, you can remove all of the holes together. Whereas in the classic, you will have to remove them one by one. I'll hand over to Preetham to for the next few slides.
Hello everyone. Thank you Rajesh for the excellent comparison of the showing FE geometry advantages over the traditional approach. As you have seen all the advantages of an FE geometry, as we have enabled all the geometry tools to work with FE geometry and how it can save users time. So let's get back to what we have added for 2022 on the traditional CAD geometry tools. This is one of the tools that we added, unsplit. So you can see that you can switch between the split and unsplit using this arrow under the geometry context. Um, we had provided some of the tools under split itself to be able to remove the scratch uh, surface splits or removing the fixed points. But now we have added a dedicated tool to unsplit these things. So it becomes easier for users to know that they can unsplit the or remove the split edges and fixed points. You can also retain the surface to its original state by unsplitting. So these are have been migrated from the panel which used to be called untrim. So here is a small video. You can see that you can just select fixed points to be removed by window or individually. You can remove the scratch lines from the surface. You can also remove these cuts, keeping the fixed points, extending the edges tangent, or you can also remove these holes as well. So there are different options that you can look under the unsplit. So this is a small video. Another tool that we migrated from a panel is what we call it as an auto cleanup. In under the batch tool for defeaturing, we had only few options that were supported before, and we were missing the auto cleanup functionality to be migrated to panel. Now, what we have done with this functionality to by migrating completely to batch tool is that you can give criteria and param files in that session, and the geometry cleanup will be carried out based off that. These options which are related to geometry cleanup are only shown when you go from the batch and click on the parameter. So we don't show all of the options, so it becomes easier for the users to know and understand what exactly is carried out under the batch auto cleanup, the geometry cleanup. So you can see all of these things that are shown. So you can see that the quality correction and unwanted things which are related to meshing have been removed in the geometry cleanup, which is the auto cleanup functionality. I think Radesh already mentioned some of the enhancements to surface patch tools. Those were related to stitching, detecting the uh, surface patches properly, the loop detection. Some of the model tools were broken. So some of those enhancements and bug fixes have been done, which are very important. So I want to mention it. I don't have anything to show as such, but those are the things that we have also improved in the under the surface patch tool. Now, coming back to 2D meshing. For 2022, Radesh covered some of the new HyperWorks workflows with the associate context and the direct mid-mesh extraction in FE geometry. From the capability standpoint, we have added the aggressive quality correction in batch measure, and I'll go over that more in detail. Uh, FE geometry support is also added for the 2D meshing and editing tools that we have seen, some pieces that Radesh has shown. And all the mid-mesh editing tools now have been enhanced to also take into consideration the advantages of FE geometry. Under the capabilities, some of the mesh controls with the local map mesh, I think Radesh has already gone through, so I won't repeat those things here. So from the batch measure standpoint, we added this parameter under quality correction called as aggressive quality correction. This is directly driven by the customers who do not want to or their first priority is to get zero failed elements, and they would not necessarily be bound by the limits of the moving of the nodes. So what happens is we try to uh, be bound by these things wherever possible, but if users have checked this option on, we go very aggressively in node movements to reduce the failed element quality. So some of the features might be or feature lines might not be adhered, but that's the idea, is to not capture some of the features which are very complex and get zero failed elements. So again, this is an option for the users. If users don't like it, they can always revert back to the main uh, more traditional approach. So here is an example where with the same quality criteria and parameter file, we get about 65 failed elements with certain node movements. By keeping the node movements values similar, we can get zero elements failed because now it is moving those nodes very aggressively, which are anywhere from 20 to 30% of the given target element size. It also fixes a lot of the warpage corrections that we had issues with. So now you can get to more zero failed elements using this particular parameter. The other thing, as we always keep an eye on, is how we can improve the mesh flow. So this is a continuous process, as we have been doing it from last so many versions, and we are taking one area at a time and trying to improve the look of the mesh. The main thing here in identifying the body fillets is that what are really the body fillets, right? So if you consider a part, you will see that certain fillets are going from one end to the other end, considered as complete body fillets, right? So this is a bigger regions and huge regions. If we identify those, and if we identify and also adhere to our parameter given for the fillet recognition and meshing, then automatically the whole part kind of starts looking better. So if there is a fillet line running across the part, and if we map that properly, then it also looks good from the mesh flow standpoint. So here are few examples that how we manage these body fillets. Even if those are variable fillets, even if certain features are coming into those, as you can see that we try to adhere to the parameter file and try to map it very nicely. So that's another functionality that we added towards improving the mesh flow under batch measure. And that's about it from my side.
So we move on to the mid-mesh workflow and the capabilities that has changed in HyperWorks 2022. So from the workflow point of view, mid-mesh remains to be the same, have the same workflow. So basically you would extract, do topology editing, rebuild, and then do thickness mapping. The major change that has happened is in mid-mesh, the output, as you see here, is always FE geometry. So there's no more 1D lines. There's to be taken care. So everything is would act just like FE geometry. Some of the improvements we've made to um, for along with it, we've made a lot of changes to some of the tools which can work more efficiently with FE geometry. In the case of repair, it's either a surface selection, uh, a patch of surface that can be filled, or as well as the loop detection. So in case you had clicking on a single edge, basically you would see here it would highlight the complete loop that goes around. So wherever you had multiple loops, so you can fill them quickly by selecting one edge and then click fill. So it fills each face at a time. So this is much more efficient to when we delete not so corrected mid-mesh extracted output. Um, Here's another example. So where if you have a lot of intersections, you don't want to be fixing this topology and doing element edit and stuff. The easiest way is basically um, delete the elements around it, create the lines, and basically you can fill them quickly using the repair fill face tool. Also, basically, when you fill a face, you have this option merge. If you don't want to merge them, it basically retains the edges as well. The mid edge tool, basically, when you create a mid edge from the direct mid mesh, we create the FE line as well along with it. So it's basically to fill a quick patch, and then when these areas are filled, basically the line gets converted into the edge, and there's no more free FE line anymore. And the edit topology tools have also been enhanced. So working on edit topology is just like working on CAD. Like if you do a node to node split, you would see the surface that is basically been created here. Here we are doing a node to a surface edge split, which is the shortest distance. The next item here would go to a node to a selected point, and then you would do a radial or a mixed stuff. During all of this, you would really see there is these edges and there's no more 1Ds interfering. Here's an example where you have a big surface and you want to create a patch of elements. You can use the edges option from the edit topology. So let me just stop here. So from the edit topology, we have two options basically with line. So when you select basically an edge on an FE geometry, we basically have this option to suppress. Basically, the edge would be removed. If you select a line, basically, if I can play it more here, if you select a line on the CAD, basically you will have the imprint option. And also from the imprint, we've automatically what we've done is when you do an imprint, we automatically do a align option as well. So basically, the line you select to imprint will be used, and then you can just hit the align button. So there's no we've reduced the step of moving from one context to another context. Um, Aligning of FE geometry is much more simple now. Is just like surface selections, where you would select the source and the target to with which you want to align. Here we're doing this aligning of elements to surface, um, aligning of edges to CAD lines, and aligning T edges to surfaces. So basically, all throughout this editing process, you are working with edges and surfaces. FE geometry is supported under the general 2D mesh context as well. So you could do either element selection, and then if you do a mesh, you would have all of the density to be edited, or you could also use surface selection of FE geometry and do the mesh as well. So throughout this, we have similar workflows that used to be working with CAD plus mesh as well. Also, all of the edit element tools have been instrumented to work with FE geometry. So, be it move tool, so it understands it has a topological edge, and when you move a node along the edge, it moves along that topological edge. Or whether you want to move a node or to normal to the surface. The split and the combine tools are also instrumented to work with FE geometry. Uh, Also with the replace tool for FE geometry and the density tool. In the previous case, when we had these 1D edges, we were never be able to adjust the densities. Now with FE geometry, you will be able to adjust densities and get the mesh um, flow you want. So density and remap did not work well along with ND, so everything has been fixed with FE geometry. I'll hand over to Yashwant for the remaining session.
Thank you, Radesh. So today I will talk about last part of our presentation, wherein I will talk little about new context, which is associate context workflow, and the mesh control enhancement related to 2022. So we have added this associate context to support various use cases of node and element association to the original CAD. So I'll directly jump onto the demo part here. So in this case, I have loaded the simple model. So this new associate workflow is incorporated under edit element. So once you enter to this context, if you hit find button, what we do is we scan through displayed nodes and we identify what all nodes are non-associated. We list them under this small legend, and we also add them into non-associated nodes to the guide bar. You can also reset that, and you could see that we have added the visualization for each type. Nodes which are not associated, we put into something, and we color it differently. And if I suppose on associated to points, you could see which nodes are associated to your vertices. You could visualize using this option. And then if you want to visualize which nodes are associated to lines, you could enable this. I will just change to different color. Yeah, you can see surface edges. Basically, we color it differently so that you will get to know which nodes are belonging to which um, CAD entity. So similarly, which nodes are associated to surfaces, you could see using this. So currently by default we kept to non-associated so that we don't get performance hit or anything, because these are the graphical things, so it might be costly. So we currently kept to non-associated. So here what you can do is this workflow is pretty much one-click solution we provide. You come here, you just hit find on displayed, it will scan and then it will add everything to non-associated. You could define your two of the tolerances. One is associate tolerance. Snap tolerance is not required in case of target is not selected. So in this case, software itself identifies the snap tolerance and does the association. Now you see the non-associated node count came to 0. So you might be wondering, these nodes are still not moved, and association is saying that all nodes are associated. However, you can do, I'll just do undo, and I have the option to whether I want to move these nodes to on project onto the original CAD, or I want to leave them into its current position and then associate it. If I say move these nodes, those nodes will be projected onto the original topology, and you could see all of these are associated. If I say show me all the nodes however they associated, you can just say all, and and you will get to know which node and however order they are associated. Also, we have this disassociate functionality under drop down menu. I talked about associate. If I say disassociate, since I have everything associated, I could just come here and then select all of these, and then I can just execute the disassociate. Now you see everything got disassociated and your count, node count became 1103. So basically, you can go to the associate function again, query the nodes, or else you can do that. If you don't like automatic way, you could always select your nodes or element, and in this case, you could select the set of nodes, and then you could select your choose your target. In the target, we have these CAD entities. In the source, we have AP entities, nodes and element. In the target, we have the lines, surfaces, points. If you have solid as well, we facilitate similar to panel, node edit panel. So you could select your source and then you could select your CAD here in this case, and then you can associate. So this way it will update. This is more of manual process. Other than that, what you can do is like you can just do a find option and then we add everything here. You don't have to add. When we don't add anything, software itself identifies scans through these two tolerances and it identifies the search the parent CAD or the underneath CAD, and then it does the association. So main use cases were like in case of aggressive node movement, and if you have some region you have broken your association, you would like to associate or change that and disassociate. All of these you could do with these options. Like let's say I have the another use case wherein you have only CADs, you don't have CAD faces, CAD surfaces, and you bring in the mesh. So using import option, let's say you bring in the mesh using solver file. So this is mesh generated on mid surface basically. So now I know none of the elements or nodes are associated. I could just do a find. I will get to know all of these are unassociated. So what I can suggest here is like this associate tolerance is nothing but your you could define average size. In this case, I know my element size is 300 plus, and my snap tolerance is 1/10 of what I define associate tolerance. Or you could go with less than minimum size so that we don't disturb any of the previously meshed cases. Here, let's say I define 10% of my associate tolerance. If I do associate, it associates all the nodes successfully without any trouble. So yeah, I'll move on to the slide. So associate tolerance is nothing but distance between your source AP versus your CAD, parent CAD. In case of snap tolerance, we have two snap facility here. If suppose you have a node which is already associated to surface, but you don't like it, you want critical the point needs to be covered. So we can use this. This node can be snapped to a line, or it can be snapped to a points or vertices. So vertices is currently the priority. In case of manual association, we take this tolerance and we associate to the. So moving on to the next enhancement. So that's all about associate. Now I'll show a little bit talk about mesh control enhancement related to HM and the feature based mesh control. So let me jump directly to the demo. In the mesh control, we have added new map based mesh, and then on top of that we provide the biasing as well. So earlier we had size and bias and surface deviation, edge deviation, and other stuff covered. But since we have the templates ready in the geometry general context, so similar functionality, there were a lot of requests regarding the mapped mesh to cover CFD use cases. So here I have defined the mapped mesh, and I will show you how it works and use cases part. So if I go to the component, I will just hide this. So here is the CFD example wherein they wanted to create a map mesh onto these front-facing leading surfaces or the edges where they want particular map mesh onto these one, and the rear edges as well. So with a particular number of layers and only chord meshes. So So in the map mesh, I have defined these 15 surfaces. If I review this, these I have added as a mapped surfaces. I have defined the mesh size and chord and number of densities and other stuff. So similar to this, I have added the rear edges as well with a number of layers at least two, and then similarly I have defined edge biasing onto these one. So I will just execute the mesh control. In the other controls are these regular controls wherein you define different sizes over the wings and the other parts. So let me execute the mesh and show you how it looks. Okay. Now if you see that the front facing surfaces I had defined with the map mesh, you would get all the chord elements here. So similarly, you would get tail faces as well, the number of layers and chord meshes. So these are the ones. So rest all will be meshed according to your other mesh controls defined. So basically the edge deviation I have defined is from this. On this face, what I have done is like I have given some growth to this layer from this central line to the going away. So you can see the sizes, it is growing from center to bottom. The map mesh and edge biasing, these both are newly added local controls in the under surface mesh. So moving on to the feature-based mesh control, we have added the couple of options in the global control. I will show demo directly in this case as well. So I have these two examples wherein I will show how the global identification of features and mesh differently works and how that affects. Basically, these higher curvature regions, like say a fillet region and the hole faces or the cylindrical faces. So those will be treated as a spatial feature. User doesn't have to always select them. The exactly similar part which is mirror of this, I will mesh with without feature identification enabled. So if you see the both the part, if we compare, the top cylindrical face was meshed with Altair, that is map mesh. And then here, if you see this for this part, I had disabled that option. You could see this is meshed with a regular tria instead of Altair. You can also see this fillet face, which is map mesh, and wherein in this part you could see this is not properly mapped. You can see the tria concentration and flow is not all the trias are trias. So this is newly added option. So I'll move on to the next enhancement. So in the same global control, we have this washer, global washer creation available. So I will go again to the session. So in the global control, if you by default this option is today off. If you want to create a washer for the selected surfaces or the parts, it works well with CAD format file, native reader file or the native CAD file, wherein I have defined my ratio of the inner circle, inner radius versus outer radius, and number of layers I could define here. So user again user don't have to select any of the circle, similar to what we have the washer mesh control. So here it is global option. If the selected part has holes, it will detect them and create the number of layers. I will just execute and show you. If I select all of these surfaces and mesh it, okay, you can see here there are two layers of mesh washer created. You can around all of these holes, you could see the washer created. So last enhancement is like, yeah, let me go to the, yeah, in the phase control, we have added the layer option wherein if user want particular phase to be meshed with the layer option, again, I will show this as demo last. Okay, in this case, this is not under global option, but this is under phase control. You have to select phases. In this case, I have selected these matching phases wherein I wanted to create 4 layers with a stretched option. So basically, there are two options in the layer type. One is stretched and the other one is uniform. When you say stretched, because selected faces has the different width here. If you see the on top, it is smaller and then bottom it is larger. So in this case, stretched option type works good. If you have the constant size width, then in that case you could go with uniform as well. So in the global control, I have defined everything. In the phase control, I just selected these couple of phases and then I will just execute the mesh. You could see these two phases coming with 4 layers mesh. With this, I think I'm done with today's presentation. So